So now we're going to do some examples of finding antiderivatives, and I've picked out some exercises from section 4.8 in your text. So in the first case it says find a general antiderivative of this function f of x, and when we see the word general antiderivative we know we're going to have to put a plus c on the end of whatever antiderivative we find. And it may have occurred to you when we were doing the first example that when we have our given function as x raised to a power, how we might go about finding the antiderivative for that. When we find the derivative, we bring the power down in front as a multiple and then raise x to one lower power. To find the antiderivative, we do exactly the opposite, so we raise x to one higher power and then divide by that power. So that's how we can find antiderivatives for power functions. And so this little f in exercise 1 is a sum of power functions. It's a polynomial, and we might rewrite the first term instead of just plain 1/2. We might rewrite that as 1/2 x to the 0, just so we can see where that's coming from, and that'll make it easier to use the antiderivative rule that I just wrote up above. So this cap f antiderivative, I'm going to take, for example, on the first term, my constant multiple and carry it along, and then I'm going to raise x to one higher power and divide by that one higher power. And on the next term, I'm going to keep the 3/4 constant multiple, and then I'm going to raise x to one higher power and divide by that higher power. And then on the last term, I'm going to keep my 4/5 constant multiple, then I'm going to raise x to one higher power and divide by that higher power. And again, because it asks for the general antiderivative, I need to add on a plus c. And then I can think about what kind of simplifying I might be able to do. So I've got some cancellation here. So my cap f is 1/2 x, or I could write that x over 2, plus 1/4 x cubed, or I could write that x cubed over 4, minus 1/5 x to the 4th, or I could write that x to the 4th over 5, plus c. So anytime you find an antiderivative, you can always check that you found the correct one by taking the derivative of the antiderivative. Whoa, what? When you take the derivative of the antiderivative, you should get back what you started with. So now if I take the derivative of this cap f, derivative of 1/2 x is 1/2. Second term, power 3 comes down in front, and x gets raised to one lower power. Third term, power 4 comes down in front, and x gets raised to one lower power. And again, we don't really need to write it, but just to be explicit, the derivative of any constant that's added there will be 0. And so this matches the little f that I started with, 1/2 plus 3/4 x squared minus 4/5 x cubed. That was the original little f that I was given. So in fact, this worked.